Video lesson 3, more on compound interest. This lesson will focus on different compounding periods. So what is that? What are compounding periods? Compounding period is just a fancy word for different intervals of time. So what if you can get interest on your money at different intervals of time in 1 year instead of just once in the year? Would that earn you more money? So what do you think? Do you think that if you can get 7% at interest within the year given to you at different intervals of time within the year, will that earn you more money or less money than if you just get it once in the year? The different compounding periods are as follows: annually, semi-annually, quarterly, monthly, bi-weekly, weekly, and daily. The question will specifically say compounded followed by one of these terms. So you have to highlight that word so that because that's going to affect how you enter the values into the equation. Let's see how accumulated amount is affected if the interest is compounded semi-annually. So take a look at the left table. This table is set up so that you're getting payments compounded annually, and we're looking at the amounts over simply 2 years. So year 1, it's $600 at 7%. So it's still the same example from lesson 1 and lesson 2. So the accumulated amount is $642. Then because it's compound interest, the $642 becomes your principal. Multiply that by your interest rate of 7%, and then you add that. And so at the end of year 2, you get $686.94. Now let's assume that you still have a principal of $600, but instead of it being compounded annually, as in this table on the left, we're going to compound it semi-annually. So our principal is still going to be $600. Now semi-annually means twice in a year. So instead of 7% at the end of the first year, we're going to do half of 7%, which is 3.5%, twice a year. So it's still a total of 7%, but instead of getting 7% at the end of the year, you get 3.5% twice for a total of 7%. So at the end of 6 months, you're going to get $600 times 0.035, because it's half of 7, and that gives you $21. And then we add the principal and the interest for a total of $621. Now, because this is compound interest, the $621 now becomes your new principal, so $621. So at the end of the first year, we still need to get the remaining 3.5% on our money because we've only been given 3.5% of the 7%. So it's going to be $621 times the remaining 3.5%, which is 0.035, for a total of $21.74. Adding the principal to the interest gives you $642.74. Now this becomes our new principal at the 1.5 year mark. So we're going every 6 months because it's semi-annually. So at 1.5 years, it's going to be $642.74 times 0.035. Again, because it's 7% for the year, and because it's halfway through the year, it's half of the interest. And that's $22.50. And then adding the principal and the interest gives you $665.24. And now $665.24 becomes your new principal. The interest here is $23.28, and that's because I multiplied by 0.035. And then for a total of $688.52. So if this was compounded annually, at the end of 2 years, you have $686.94. But at the end of 2 years, compounded semi-annually, you have $688.52. So I want you to think about why you actually end up with a little bit more money if it's compounded semi-annually versus compounded annually. And we'll talk about that tomorrow in the follow-up lesson. So here's the formula that you saw already. So I is your interest rate divided by your compounding period. Now you know what those different compounding periods are. And N is still your time in years multiplied by your compounding period. All right, so here's a table that's going to help you determine what the calculation is going to be depending on the compounding period. So if it says that it's compounded annually, you actually don't really need to do anything. The interest rate is what it is because you're just dividing by 1, and the time in years is what N will be because you would be multiplying by 1. But if it's semi-annually, semi-annually means you're getting interest twice a year, so the interest rate has to be divided by 2, and then your number of years has to be multiplied by 2. Quarterly, your number is 4, monthly, 12, weekly, 52, bi-weekly, that's every 2 weeks. So if there's 52 weeks in a year, if you're only doing it every other week, that would be 26, 52 divided by 2. And daily would be 365, so just assume it's 365 and it's not a leap year. So just use 365 every time for a daily. Now notice that the number that you're dividing by is also the number that's being multiplied. That's always the case. You're never going to have a number that you divide by for interest and that you multiply for N that would be different. So if it's 52 dividing for the I, it's 52 multiplying for the N. Okay, these numbers will always be the same. You're not going to get one that's different. All right, let's move on. For each of the following scenarios, state the value of I and N. So we're not actually calculating compound accumulated amount with compound interest. We're just making sure that we know how to calculate I and N in order to put them into the formula. So if it's 5% compounded monthly, so our number there is 12, and it's 4 years. So let's just recall the formulas at the top. I was our rate divided by the compounding period. N was our time in years multiplied by the compounding period. So CP is just compounding period there. That's the number based on the frequency. Okay, so I is going to be the rate as a decimal, 0.05. Remember to do that, you just take your rate as it's given and divide by 100. Divided by the compounding period, which is monthly, so it's 12, and then you just get your calculator and you do that, and the answer there is 0.004167. And you want to try, if the decimals keep repeating, which I believe this one continues as 6666, you want to try to keep at least 4 numbers other than 0. So beyond the 0, keep 4 digits. You'll get a much more accurate answer when you calculate the accumulated amount. N is your time in years, so T here, which is 4, multiplied by your compounding period, which is monthly, which is 12. So N would just be 48. Okay, the next one, 6.2% as a decimal is 0.062. The compounding period is semi-annually, which means twice a year. So you're dividing by 2. And then if you calculate that, it's just 0.031. N is going to be the number of years, which is 8, multiplied by the compounding period, which is 2. So N here is just 16. And the last one, 0.3%. Be careful here, because when you divide by 100, it's a very small number, and that's okay. So you get 0.003 divided by what? Our compounding period is quarterly, which means 4 times a year. So you divide by 4. And we get 0.00075. And N is going to be the number of years, which is 2, multiplied by the compounding period, which is 4. So our N value is going to be 8. So this is probably the hardest part for using the compound interest formula, is calculating your I and your N. So if you can calculate I and N, then I'm sure all of you can just put it into the formula with the principal and then calculate what the accumulated amount will be. And we'll do examples like that in the follow-up lesson tomorrow. So for now, that's it. And you can practice some of these questions tonight. Page 7 is still in last night's homework, but it's got number 15 and 16 deals with the different compounding periods. So you can do those 2 questions now. And then page 8 is officially the new homework for the new compounding periods. So that's on page 8, numbers 2, 4, and 6. Have a good night.
Hi.
I have